Okay, we are going to go through some shortcuts. So one way to prove two triangles are congruent is if you prove all the sides and all the angles are congruent to each other. But that takes a lot of work. Those proofs are like a mile long. So luckily, because of this thing called triangle rigidity, there are 5 shortcuts we can use to prove two triangles congruent instead. Now, triangle rigidity says that if side lengths of a triangle are given, then you can only have one shape. So if I were to give you 3 sides to a triangle and you had to create the triangle, all of you would end up creating the exact same triangle because those lines are so rigid in how the triangle is. So the first shortcut to proving triangles congruent is called side, side, side. So if you know that 2 triangles have 3 congruent sides, then you don't have to know anything about the angles. There's a lot of math we could do and prove that those are also congruent. But as long as we know the 3 sides of the triangles are the same, then you have side, 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 or SSS congruent. So this is the first way to prove 2 triangles congruent. This is to use SSS to explain why ABC is congruent to DBC. So what's given to us is that AB is congruent to BD, because they both have 1 hash mark. Then looking at the 2 hash marks, I see that AC is congruent to CD. The last side that we're looking at with these 2 triangles is BC. Now BC, it's the same line, like they share a side. So I'm going to say that BC is congruent to BC. I can do this because of the reflexive property. This is one we learned a long time ago, that something is congruent to itself. While it sounded ridiculous at the time, these are the scenarios that we use it in. So now I can see from the picture and from my reasoning that all 3 sides are the same length. So I can go ahead and say that those 2 triangles are congruent because of side, side, side. This is like a mini proof.